10 more minutes, I mean 5 more minutes. So let's start with the today's webinar. So today's webinar has been titled as Assessing Product Reliability and Accelerating Sustainable Development with SIMULIA or ABAQUS. So before getting into the webinar, let me introduce myself. So myself, Ranjit Kumar. I am working as a solution consultant, especially for CAE in AGS Computers India Private Limited. Okay, right. So let's get on to the webinar. So what the usual design process that has been followed by us while developing a product? So we have been doing the conceptual design, and we have been developing that conceptual design into a detailed design so that we can either trade off some of the studies, so that whether which parameter has to be established or which parameter has to be enhanced, so that with that particular parameter we can develop an entire product in an efficient way. So all these are compared and contrasted so that it can give you a design which is refined, in the sense it will give you a total view of your product. So with that design, that is detailed design, we will be doing either physical testing or virtual testing. So here in this part, our virtual testing is going to play a major role, since this virtual testing will reduce our cost that we are going to spend on your physical prototypes. So after the all the refinement of your design and enhancement of your product, we are getting into the production stage, where you will be reducing the cost that you will be investing on earlier stages of your product. So how actually this that is the virtual validation can be achieved is by the initiation of the conceptual design, as I mentioned earlier. So this conceptual design can be either with the help of the gut feeling that an engineer or designer has, or it may be due to the vast experience that he has during development of any new product in his or her organization. So with that gut feeling or experience, or also even the hand calculation, that is the classical theory with which he has been validating the entire product, will be put forth put into use, so that he can give a complete product. But what are all the consequences that he or she is going to face is either over dimensioning or the non-optimization of the product, which will leads to a product that won't be giving or won't be giving a satisfaction to the customer that we are going to supply the product with. So all these parameters are to be considered, and we are going to give an detailed design. How this detailed design is going to be established is either done by an analyst or an engineer who will be creating the prototype, as I mentioning earlier in the usual design stages. So these things are carried out with lots and lots of efforts. Either it may be giving lots of time to validate an entire product, or it may be giving lots and lots of cost so that we can give you a complete product with which you will be enhancing, performing a complete satisfaction towards your customers. But all this can be done with the help of the simulation tool, which is called 3D experience or Simulia, or we can also say that ABAQUS. So how we are going to do? We are going to do by eliminating the prototype, and also we are going to reduce the cost that we are going to spend to establish a material, so that you can complete your entire design process, with which you will be getting an utmost capabilities to perform. So all this can be put forth with the help of key important softwares that we have. It is either it may be SolidWorks or any CAD model that you are going to have, whichever has been designed with your any CAD model. We have an established platform where you will be using any kind of CAD model data, with which you will be performing any kind of simulation with the help of 3D experience Simulia platform. Okay, right. How we will be doing? We will be doing with the help of a world leading trusted finite element analysis software that is called ABAQUS. Okay, so all these capabilities that I am going to mention in the upcoming slides are imparted with the solver, which is an leading finite element software that is available in case of our world, which is called ABAQUS. Okay, so any kind of complexity of problem, or any kind of multi physics that is involved in your problem, or any kind of co-simulation in the sense it may be either mechanical or thermal or even electromagnetics. So all these kind of simulation problems can be analyzed with the help of 3D experience works SIMULIA. Okay, so what are all the various fields that can cover in this 3D experience Simulia are structures, fluids, electromagnetics, plastic injection, and motion. In the upcoming slides, I don't want to give you a much detail about the capabilities entirely possessed by this 3D experience Simulia, whereas we are giving some of the highlights with which you will be doing highly explicit kind of analysis. So to start with, I will be introducing this structure portfolio where we will be having a capability to solve right from static to dynamic conditions. We can say that from static to dynamic condition, the complexity of problems can be at the maximum side, and we can solve these kind of maximum complexity problems with the help of Simulia structures portfolio. In the dynamic side, we have nonlinear capability also, where we will be covering either it can be implicit or it can be explicit. We all know the difference between implicit and explicit. Implicit is a kind of natural phenomena where you will be facing every equilibrium stages, right from loading condition from 1 kilogram to 100 kilogram, or whatever it may be. It is of the stages with which we will be seeing any kind of problems. Whereas in explicit analysis, all this kind of complexity comes into picture. For example, it may be either a geometrical deformation, or it may be due to the material behavior, or it can also be due to the behavior entire complexity put completed into a single problem, like nonlinearity with geometry and nonlinearity with materiality. So all this will be in a single problem. So for this explicit analysis, we can say explicit can be conducted in a fraction of seconds. For these particular dynamic explicit problems, we will be saying or putting a example called crash analysis. In this crash analysis, we all know that lots of loads will be comes into picture, and also we will be seeing lot of deformation, right from crumple zone to the bumper that at the other side of your car. So all this will be getting into our problem, and these can be analyzed easily with the help of nonlinear dynamic explicit problem. Apart from that, we will be having a capability called multi-step, where you can use with an edge to analyze various kind of deforming or deforging. So forging problems and all easily can be achieved with the help of this multi-step, since forming process consider with multiple steps with which we will be creating various kind of profiles, right? So those kind of problems can be helpful, achieved with this helpful multi-step capability that is present. So other than that, we will be having most of the similar capabilities that most CEA tools will be having, right from frequency analysis, thermal analysis, buckling analysis. So all those kind of analysis. And there is an exceptional capability in the structure phenomena, portfolio. We will be calling it as material calibration. So this material calibration will be used to calibrate any kind of material properties. Like for example, you will be considering for an hyperelastic material, where you will be considering for neo-Euclidean model, or Ogden model, Rio. So all these kind of models can be used to establish the behavior of any rubber material that you are going to consider for your product. So how we can finalize this particular model will be used or not is the thing that this particular material calibration will be used. So with the help of material calibration, we are giving some test data, either it may be uniaxial or it may be biaxial, or even can use triaxial data. So all those data, test data, are given as a feed towards your material calibration capabilities, and where you will be checking for which particular model will be a perfect fit, a regression fit to your model. So with that model, you can proceed to any kind of physical simulation that you want to achieve. So this will be helping you for that particular behavior. Apart from that, we have a dedicated technology, especially for fatigue or durability, that you are going to consider for, that is called FECF. So this is also imported towards your structural especially SIMULIA portfolio, structural portfolio, where you will be using to enhance your products life cycle also. Okay, so these are all some of the capabilities which are highly advanced from other CAE tools that is available in case of our simulation portfolios. Okay, right. So these are all some of the examples just I want to give you. So this is an example of explicit analysis, where a bat has to be striked on a wing, so that this wing's deformation can be seen, whether this will be creating a catastrophic effect into an entire plane or not. So those kind of analysis can be easily done. Apart from that, there is an sheet metal forming process, where we will be considering for different steps, that multi-step that we are going to consider. And you can see over here, we can also easily do this problem without any hiccups. So there is an capability to do blow molding, and SPH capability, smooth particle hydrodynamics capability, to check for the bottle crush with liquid inside of it. And also we can check for any blade damage that has been caused due to an misplacement or misalignment of your drone onto any static structures. So apart from that, we can also do that car door crash impact analysis. So all these kind of complex problems can be easily analyzed. Okay, so what are all the benefits that we are going to get us? As I mentioned earlier, it has a world class technology called ABAQUS solver, and we can also have an capability where you can scale up your entire portfolio according to the requirement of your project. It may be either a small problem, where you will be just checking for the strength capability of your product, and if it has multi physics that is involved, then we can go for various capability, where it can be achieved. Okay, so whatever may be the complexity of the problem, depending upon your timeline, you can adjust from lower grade to higher grade. Okay, right. So and we have a dedicated cloud computing capability, with which you can easily solve any kind of complexity of problem, and we don't need to invest high on your computer system infrastructure. Okay, right. So to move on, the next field that I want to introduce, or I want to give an overview, is fluids. So here we will be using a RAN solver, Reynolds average Navier-Stokes equation, that is Navier-Stokes solver, where we can easily define the boundary layer between any kind of fluids and structures, with which you can get an higher accuracy of results when we compare for the normal Navier-Stokes equation solving flow simulation capabilities. Okay, right. So what are all the physics that we are going to cover? Is it may be either steady or transient flows, it can be laminar or turbulent, Newtonian, non-Newtonian, or any kind of multi-species modeling, for example multiple rotating frames, or even porous medias that we are going to consider. So all these kind of problems can be easily solved with this particular RAN solver. Okay, so after that, in the thermal side, so whenever we are going to consider for an fluid capabilities, that is computational fluid dynamics capabilities, we have to say that there should be a thermomodeling, right? So for this particular thermomodeling, we have capability to solve for any kind of conjugate heat transfer problems that we are going to consider. It can have surface to surface radiation, or even it has to be considered the solar radiation. So all those kind of problems with conduction, convection, and radiation, that is the basic phenomena of heat transfer. So all those can be easily solved with the help of FMK, I mean fluid dynamics capabilities that is available in case of 3D experience. After that, we can also do human comfort parameters, where we will be reducing for PPV or PMV, predicted mean vote, or percentage dissatisfied. So those kind of parameters can be checked with the help of fluid mechanics capability that is available. Okay, right. So in case of meshing, so as I have forgot to say something called meshing. So meshing will be a complete parameter where it will determine the boundary layers between solid and fluid. For this particular meshing capability, we have a capability called X dominant meshing, where most of your meshing will be dominated with X elements. Okay, so we can say that this will be a concrete element type with which we can apply to any kind of fluid structure interaction problems. Okay, right. So after that, what we are going to do is we are going to do for any kind of shell meshing that are also available for any thin solids. Okay, right. So, what are all the mainstream applications that we are going to apply, especially for this fluid capabilities? So, any kind of engine thermal design which has to be enhanced with the help of fluid capabilities, then we can proceed it with that, with of this fluid dynamics capability, and also any kind of fluid structure interaction, as I mentioned earlier. So, this is a classical example of fluid structure interaction, where any kind of material that is stored inside a solid structure will be squeezed out of the product. Okay, for example, a shampoo bottle which contains shampoo. So these kind of problems can also be analyzed. Apart from that, exhaust system, HVAC for human comfort, electronic cooling for heating capability that is available, and also drug delivery and infusion. So these are all some advanced capabilities that is available in case of our fluid mechanics capability. Okay, right. So apart from that, what will be the benefits? So in the benefit side, we can say that there will be an interassociativity from CAD modeling to the importation of your fluid problems. So after that, if we want to import any kind of fluid results to one structure, then that can also be done. So that is called fluid structure interaction. So these all kind of any complexity or any associativity problems can easily be done by with the help of this particular capability. Okay, there is specific kind of turbulence model that is available in case of our capability, fluid capability, that is called K omega and K epsilon. So in this, we can say either it can be used for internal flow or it can be used for external flow, depending upon the Reynolds number or depending upon the problem that you are going to solving. We can say that this particular turbulence model will be efficient to go with. And we have an specified turbulence model which is called Spalart Almaraz. So with that, you can solve any kind of aerodynamical problem also. Okay, right. So those kind of aerodynamical complexity of problems can also be achieved with this fluid domain. Okay, right. So moving on, what we will be seeing is we will be seeing about the electromagnetic capability that is perfect. Okay, so in the electromagnetic capability, what we are going to do is we are going to do to validate for any kind of EMC and EMF compatibility issues. Okay, right. So with that, we can say this particular electronical device also be done with this help of electromagnetic engineers note. Okay, so what this electromagnetic engineer will be having is we will be having a dedicated CST Studio suite, where I think most of you are familiar with the CST Studio suite. It is established long back and it has been in the field for almost 4 to 5 decades. So it will be used to deliver any kind of problem that can be analyzed, right from static or low frequency analysis to the high frequency analysis also, like microwave or RF optical problems that we are going to consider for. Okay, so next to that, what you will be seeing is this is an highlight video, I mean highlight slide, where you will be seeing we can check for any kind of problems. Like you can see over here. So here it is a representation of electromagnetic field that is available in case of any moving transportation buses or flights that is available. So with that, we can say this is how the interaction between the any electronic devices that has been present in your transportation facility, and it will affect the signal disturbance between any two components or not. So here is a classical example of this coincide I mean coincide interference detection of your various antennas that is present in case of your vehicle. So benefits will be, we can easily identify and mitigate any kind of electromagnetic capability, compatibility, and also we can check for any kind of interference between any kind, one or two, two or more electronic devices. Okay, so that we can say that this particular electromagnetic radiation that is developing from this antenna is clashing with the other thing. So clear position of antenna will give an enhanced coverage, whereas from others will be giving the reduced coverage. So these kind of analysis can be easily done. Okay, we can go for any design alternatives with this kind of benefits. Okay, so next to that, what I want to give an introduction is about the plastic injection, where you will be seeing most of the designers aiding plastic materials that has to be used, that will be used in case of any plastic industries. These kind of plastic library material that is available is regularly updated by the SO system, so it can be used continuously with the latest materials also. And we can check for fillings, most of the plastic defects. Okay, so plastic injection molding defects can easily checked out, and we can avoid those kind of defects, right, from filling well lines, sink marks, air drops, or even warpage. So those kind of defects can easily addressed with the help of this particular portfolio. There are capability that is available in case of all fields that I am going to discuss, right from structures, fluids, electromagnetics, plastic injection, and even in motion also. So that is called cloud computing, where you will be adopting for any kind of core capability, so that you can solve in ease with the time that you are going to solve. Okay, right. So classical benefits that we have discussed earlier here also. So we have an interassociativity between any kind of models, and we can easily use simulate and reduce any kind of development times that you are going to waste on your product, and also respectively the cost. Okay, right. So next to that, what I want to show is the motion part, where you will be seeing many kind of problems. So these kind of problems can also be used and analyzed for its maximum attainment of velocity, or even acceleration, and the force that you are going to get on the other side. So the classical advantages that we have discussed earlier would be the same in case of this 3D motion creator. Okay, can anybody confirm me whether my audio is clear or not?
Yes, Mr. Ranjit.
Hello.
It's audible.
Yes.
It's audible.
Okay. 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 Let me share my screen once again. Okay. Right. Okay. I think my screen is also visible. So let me proceed. Okay. Directly to the presentation. Okay. I don't know where I left. I think most probably this is a slide where it gets it got disconnected. So I will just proceed with my presentation. Okay, right. So this is where we are going to see the entire automatic component, where we will be enhancing its vehicle performance and technical specifications that we are going to improve. Along with that, we are also going to subject it for any geometrical changes with respect to the simulation results that we are going to get. Okay, so all those simulation results are also analyzed so that it can be traded off with any parameters, so that these parameter can should be avoided, and with the avoidance of that particular parameter we will be enhancing the other parameters that we are considering. Okay, let me show on the slide so that you can easily understand. Okay, so all this can be, elimination of any particular parameters or including all the parameters can be done with the help of optimization, which will leads to the ultimate change of your geometry. Okay, right. So here is an example where we will be considering for various kind of parameters, especially for customer performance. Okay, so here we will be checking for the maximum rating that is going to consider for your particular vehicle has to be used or not. We will be checking for various deceleration conditions, where we will be changing for either frontal bumper sizes or the pillar dimensions, with which we will be checking for the performance, entire performance of the vehicle. Okay, let me show on the slides. So here is a what will be the parameters, or what will be the concepts that we are going to consider is, we will be checking for the safety of the entire vehicle, which we are going to get it as a 5-star rating, like NCAP, new car assessment rating. And we are also going to consider for various variants that we are going deal with, like rim variants. And if we are going to subject it for any changes, like adjustment of your ground clearance, or even your chassis modification, so all those can be easily matched. Okay, how we are going to do, how with the help of 3D experience platform. So here the complete model of the outer skeleton, BAW of your vehicle has been imported towards your 3D experience platform, and with a single click we can say this is how it has to be meshed. So we can also give mesh ruler, where it will be saying like this kind of thickness of surface will be having this kind of mesh. So all those can be easily settled in the initial stages also. Okay, right. So how we will be reusing is, we will be reusing according to the need that we are going to get. So for example, so we are going to fit it with 4 tires, and with which we will be providing it with electrical motor, or even an IC engine. Okay, so those kind of alteration can also be done, and it can also be easily meshed. Okay, after doing that we will be checking for the entire performance, especially on the geometrical side. So after doing that we will be importing other setups also, like any kind of lower guard, or even the disc brake that you are going to consider, or even the suspension system. Okay, so here is the front double wishbone suspension system, where this can be imported into our entire model, and it can be used for complete vehicle performance. So here is an example. So entire front double wishbone system with its disc brake system is going to be imported, and it can be used and analyzed. Okay, right. So the supporting system for your engine replacement, placement, can also be done. So these kind of design changes with various collaborations between various parts in a single platform can be easily done. We don't need to maintain individual folders on every project that you are going to consider. So it is a single product where you will be grouping every sub assemblies that is considered for the entire modeling of your product. Okay, right. So here is a classical example where we will be configuring your alloy wheel spokes. So with that, I mean alloy wheels. So with that, we can easily address any kind of variations also. So different variants are classical example for this is any kind of automobile, I mean automotive that is on road. We will be seeing classical top model, and to that the lower variant, and to that to the lower variant. So those variants can easily be stored in a single database. Okay, right. So moving to the other part, that is the associativity part, that is especially for the simulation part. Here what we are going to do is we are going to check for NVH, that is noise, vibration and harness. After that we will be seeing for the stiffness and also the crash. So here I will be highlighting the crash capability itself. So since this involves the explicit capabilities where drastic accidental behavior can be easily simulated. So here you can see all the four configurations which has to be checked with the simulation can be put in a common folder itself. So you can check for any variations, and we can say this particular variation can be accepted for your variants or not. So those kind of analysis can be easily done. This is a classical frontal impact analysis where you will be checking for maximum of 5 km per rpm. So these kind of analysis can be easily done. Okay, right. So after that what we will be seeing is we will be checking for the various kind of deceleration that is going to happen. With that we will be checking for either frontal damage along the full length, and also the side barrier, and also with the side pole. So those kind of different variants. So these kind of condition can also be easily analyzed. Okay, and we can say this particular validation of a full width frontal has failed for the standards that we have set it, and we can say particular model has been passed with the validation. So these kind of analysis can be easily done and upgrade, I mean saved in a common platform. Okay, right. Okay, so with that I can say everything is put in a common platform, and we can say a complete assessment of your product can be done. Okay, right. Now let's get into the change scenario, like modifying any two geometries or tweaking any simulation attributes depending upon the geometry modification that you have done. And also we can exchange the various components so that it can give you one complete performance. Okay, so this is a classical example where you will be changing for the JC's members. With that we can enhance the entire product weight also. Okay, right. So here it is a geometrical representation, here it is an mesh representation. Okay, so this is another classical example where we will be checking for the ground clearance, where some of our Indian road conditions we will be checking for ground clearance, which will give you a complete stability for your vehicle without any physical damage which will be happening due to impact of any kind of noises that is going to present in case of our environment. Okay, right. So this is an example where we will be replacing a classical electrical drive, I mean electric motor drive, into a with the help of a IC engine. So those kind of replacement, that is the change environment. So these kind of changes can also be easily done. Okay, just by clicking the replace option that is present, we can easily replace the entire engine assembly that is present earlier. So those kind of analysis, I mean sorry, those kind of replacement can also be done. Okay, with its connection behavior changes also, like this is how it has to be used in case of our simulation, those kind of analysis also. Okay, right. So there is another section which is called a trade-off study, trade-off study with which we will be doing the optimization problem. So this particular trade-off study is available in with a role called simulation collaboration, with which you will be checking for any kind of tweaking, especially on the simulation side. Okay, right? So we will be changing some kind of parameters. With that parameters change, we can say this particular analysis has to be carried out or not. So those kind of analysis can also be done. So with due to the time constraint, I will just go for the below simulation that we have done. And for this below simulation, what we have done is we have used various solvers that is present in case of our 3D experience SIMULIA's portfolio. So what are the various solvers is we are going to consider it with three different methods. Okay, so first one is with the standard static stabilization, where we got to solve for about 50 minutes. So with that 50 minutes, we got a result. And the second method that we are going to implement, that we have implemented is quasi-static analysis. So quasi-static is another classical, kind of solver where you will be achieving various equilibrium stages on the board. Okay, so for this particular thing, we will be having, consumed about 31 minutes. And with that, what we will be tweaking is we will be taking for the solver's capability that is present in case of quasi-static with explicit. So with the explicit, what we have done is we have entirely solved it in and around 5 minutes. So this is a classical example where particular solver can enhance your entire model on computing cost also. What I mean by computing cost is nothing but the solving time that you are going to invest on your entire model. Okay, so this is another example where we will be seeing for the impact on its side, where the B pillar is going to get damaged along with its base. So this particular base behavior is entirely captured, and we can say that this particular base is how going to represent for its battery pack. Okay, so this battery pack is going to get damaged or not. So we can say that this will leads to the damage to the cell that we are going to place in the complete battery pack along with its base, along with its column structures. Okay, so those kind of analysis can also be done. Okay, right. So next thing that I want to show is we are going to consider for the called side view mirror aerodynamics improvement, where we will be checking for a classical wind tunnel test, where we will be say that this particular component will have a maximum velocity attainment along this part or not, or it can induce large amount of drag or not. So this is a standard that what we have done with. So we can check for large number of nodes and elements also. See, here is a classical example where you will be seeing large number of elements along with it. Okay, so these kind of large quantity of meshes can also be easily analyzed. Okay, right. So here the boundary layers that we are considered is about 5. Okay, right. So here is the mesh distribution along with the entire setup, and what we have set set it up is with 1000 to 2000 iteration based convergence along with RNG K epsilon turbulence. Okay, so the classical turbulent model that we have discussed, right? So here what I have used is K epsilon, since it is external flow analysis. Okay, right. So these are some of the boundary conditions that I gave. So I'll just go for the results. With that we can validate so what will be the maximum velocity that I'll achieve in case of the mirror. Okay, so the pressure achieved is 951, especially on the frontal part, and the back it is around 1.2 e to the power of 3. So here, due to the a vacuum that has been created due to the disturbance of the flow right on the front and back, so the pressure difference will be the maximum and lower, okay, comparatively. So the maximum velocity that is achieved is on the either sides of the mirror, that is the 8.1 meter per second. Here you have to notice that it is meter per second, but in the input condition what I have given as 140 kilometer per hour. So these kind of higher velocities achievement on the vorticity that is achieved in case of this mirror can also be analyzed. Okay, so this is a classical example where the vorticity along with the streamlines can also be, I mean, shown in a simpler way. Okay, right. So what we have validated is we have validated the mirror force along with the total force. Okay, so in the mirror force we can say this particular limit, limit, it can withstand this force or not. Okay, right. So if with that value, if we can also change for any parametric uh, dimension which we are going to consider can also be altered. Okay, right. So here we have an high performance result visualization where we will be having a post processing capability to check for any kind of complexity problems also with large assemblies. Okay, and what are all the benefits is it is highly speed enough, and it can give you an high effective performance also. With the remote visualization we can check for any kind of problems that are also solved on the high performance computing, that is the cloud computing also. Collaborative visualization will help you to share any kind of results to the any departmental persons that you are going to have in your organization, and which will improve the product ultimately. So here what represented is we have represented the operation timing in seconds, how our 3D experience SIMULIA will be differing from the ABAQUS, that is our desktop ABAQUS. So from the 2015 version itself we will be having a higher advantage on opening the model by some kind of highly a time second difference. Okay, right. So this is an example you can see over here. Okay, right. So next, this is a frontal crash for the Ford Taurus. So what we have done is we have checked and we have analyzed for it, and we can see the difference in the opening of the model itself with the help of our 3D experience. So it takes only 18 seconds for opening up the entire model. And this is an SPH modeling where we will be having 501 frames per 8 GB. So here also we have 14 seconds for complete opening of our entire model. We will be placing the number of cores for the model is 8. Okay, so this is a classical example. So to summarize the entire thing, we can say it give you a 3D experience, especially for structured portfolio. It can give you an state of art meshing and modeling technology, and it can also implement the various engineering templates with which we can establish any kind of efficient tooling that can be done. After that, it can collaborate with any kind of organizational structures that we have, and we can scale up to any kind of multiple physics problems that we are going to handle. It has an high performance visualization tool with which we can also say any kind of problems with any kind of large number of files can also be addressed with. So other thing that I want to discuss is this is a classical example for the packaging industries where we will be checking for the packaging quality of our entire goods. So this is the goods where we will be packing with plastic members or even any other specified material with which they will be packing. So those kind of thing can also be checked where any kind of damages on the sides can also be checked for. Okay, right. So those kind of analysis can also be done with the help of 3D experience portfolio. So here is another video where we will be checking for packaging stuffs. So here we will be showing the example where the how this particular failure of this entire packaging is induced. Okay, right. So here is an example where even the uneven road or even due to the environmental structure that we are going to make this particular package to transport it with can leads to the failure. Okay, so those kind of disturbances or noise on the environment can also be analyzed. Okay, so this is a classical example. Okay, right. So we can say that this will help you to completely establish whether your backing can stand any kind of deformation that has been carried out due to the sudden stoppage of your transportation vehicle, or even the sudden acceleration that is going to happen in case of your transportation. So these kind of analysis can also be easily achieved with the help of 3D experience simulia. Okay, right. So with the kind of capabilities that I have shown, any kind of problems or any kind of needs, we can easily meet with 3D experience. Okay, right. So any kind of complexity of problems, or even any kind of multi-physics that is involved, or with the help of the high performance computing, will be eliminating any higher infrastructures that you are going to require to solve the entire problem. And you can also have the flexibility, right? From you can, whenever you want, you can scale up your capabilities so that you can solve any kind of problems. Okay, right. And there is another important point that I want to discuss is there will be a collaboration which can be achieved easily to any members in an organization. With that, there will be a continuous improvement for your product. Okay, right. So and then we are coming to the end of the webinar. I just want to share our customers, those who are using 3D experience and the Simulia portfolio. If you have any doubt, you can ask me now, so that I can clarify some of them, or else we can conclude the session. Okay, you can also write us so that we can also address you on any time. Okay, right. Thank you. Thank you, Ananda.